So we've received this single error correction code word. We've received it. It's already been generated. So we know in here we've got 8 data bits and 4 check bits. The first thing I like to do is, label everything. So this is 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. And I like to underline my check bits 1, 2, 4, and 8. Now, our objective here is to find out if there's an error, and we do that by looking at our check bits. And so the first thing, or I guess I've already done the first thing, the next thing I do is I like to write out my received check bits. So I'm going to say my received check bits, and I write them in the order of significance. So I've got 1, so 8's a 1, 4 is a 1, 2 is a 1, and 1 is a 1. So I say I've received this, and I'm just going to leave it there like that. And now what I need to do is go through and calculate what these check bits are based off my data. So I'm going to calculate C1. And of course, these aren't going to take the existing check bits into account at all. I'm just kind of recalculating them and see what they should be. So C1 is based off of bit 3, which is a 1, 5, which is a 0, 7, which is a 0, 9, which is a 1, and 11, which is a 0. So what should this check bit be if we're using even parity? Well, we've got 2 1s, which is an even number, so that means the parity bit should just be a 0. All right. Now let's go to C2. So that equals the XOR of, and we need bit 3, which is a 1. We need 6 and 7, so that's a 1 and a 0. What else do we need? 10 and 11, 1 and 0. So what should this be? Well, we've got 3 1s, that's an odd number of 1s, and even parity wants to make the total number of 1s even, so we add a 1 there. Now we've got 4 1s, and that's an even number of 1s. Now let's get C4. And that is the XOR of 5, 6, 7, and 12. So 0, 1, 0, 1. And what should this be? Well, there's 2 1s. That's an even number of 1s. And so the parity bit can be 0 there. And finally, C8. Okay, so for C8, that's just 9, 10, 11, and 12. So 1, 1, 0, 1, right? These 4 bits here. That's an odd number of 1s, and so therefore, odd number of 1s means that we need our parity bit to be a 1 there. And now, let's write our calculated check bits here. Our calculated check bits. So make sure you write them in the right order, right? C8 is here. C4 is here. C2 is right here. And C1 is right here. And the next thing we need to do is exclusive OR them together. That's not a very straight line. Exclusive OR them together. That's still the same straightest line, whatever. Exclusive OR each one of these columns, right? So 1 XORed with 1, that turns out to be a 0, 1 XORed. Let's do a different color, actually. Let's do this. So 1 XORed with 1, that's a 0. 1 XORed with 0, that turns out to be a 1, 0, 1. And so this set of bits here, this is actually called our syndrome, or I'd usually just write SYN, but this is our syndrome. Our syndrome tells us the location of the corrupt bit, if there is a corrupt bit. If this is 0 for a sec code word, if it's all zeros, that means that there is no corrupt bit. Or if it's a value, well, yeah, so if it's 0, that's basically if our received value is the same as our calculated value, our syndrome will all be 0, and that means there's no error. But here our calculated was different than received, and this is actually telling us this is the address of corrupt bit. And so the address is 5, right? Bit 5 is corrupt, right here. Oh, actually, I want red here. Bit 5 is what got corrupted. And so that means, since there's only 2 values you could have, 0 or 1, it means this is supposed to be a 1. This is supposed to be a 1. This is where the error's at. So the final step, as long as there's, well, even if there is no error, the final step is to take the data out and to fix the error if there is one. So our data, right, and we just extract the data bits. So 1, 0, 1, 1, and then 0, 1. And then as we extract it, we're going to flip this bit. We're going to say this should be a 1 as well. 1. And then we just need our 3 here, which is a 1. And this is our data. This is our final product that we're going to take. And this is what we're actually using, right? All the check bits, they just get discarded now. They've served their purpose. So that's sec code words.